So our assignment today is 1.1 independent practice. So chapter 1, lesson 1 on greatest common factor and least common multiple. Your assignment is page 11 and 12, problems 1 through 12. So let's take a look at the problems on greatest common factor first. Number 1, we are asked to find the greatest common factor for 8 and 14. So let's go ahead and make a factor tree for each of those numbers. 8 can be broken down into 2 times 4, and 4 can be broken down into 2 times 2, and then I'll just bring down that 2. 14 can be broken down into 2 times 7, and both of those numbers are prime. So then we're looking for the greatest factor both numbers have in common. So we're looking for factors that they both have in common. So I start with the smallest number first. I look at the 2's. So 8 is equal to 2 times 2 times 2. It has 3 factors of 2. But 14 only has 1 factor of 2. So the greatest factor that they both have in common is 2, as far as 2 goes. Then I look at the 7. 14 has a factor of 7, but 8 is not divisible by 7, so we cannot list that 7 as a common factor. So our GCF is just 2. Number 2, we have 21, 24, and 27. So let's make factor trees for each of those numbers, and we'll look for the greatest factor they all have in common. So 21 can be broken down into 3 times 7. 24 can be broken down into 3 times 8. And then the 8 can be broken down into 2 times 4. And that 4 can be broken down into, actually, I'm going to do 6 times 4 here just so I don't run out of space. Instead of 3 times 8, it'll just be a little bit more even. It doesn't matter though, but 4 times 6, and then 4 can be broken down into 2 times 2, and 6 can be broken down into 2 times 3. And then our third number was 27. And 27 can be broken down into 3 times 9. And I'm just going to bring that 3 straight down. So then we're looking for the greatest factor all 3 of these numbers have in common. Okay, so the 21, it only has the 3 and the 7. I look here, it only has the 2, but we already know the 2 isn't common because 21 did not have a factor of 2. So the 2 is not going to be able to be counted. It does have a 3 as well. And then I look at the 27, that's 3 times 3 times 3. So the only factor that all 3 of them have in common is a single 3. So that's going to be our greatest common factor. That's all that they have in common. That's the only number that all 3 have in common. So then let's take a look at number 3. We have 21, 35, and 49. So 21 can be broken down into 3 times 7. 35 can be broken down into 5 times 7. And 49 can be broken down into 7 times 7. And then we're looking for the greatest factor all 3 numbers have in common. And I should have gone in numerical order over here just for having a good method. So let's go in numerical order, smallest to largest. Okay, so we have 3 is the smallest number. Do they all have a 3 in common? No. The next number is 5. Do they all have a 5 in common? No. And the next number is a 7. Do they all have a 7 in common? Yes. And just a single 7 is common in all 3 of them. So our GCF is just 7. Okay, and number 4, we have 12, 18, and 24, and we are asked to find the greatest common factor. So let's break these down. 12, its factor tree can go to 3 times 4. 4 is composite, so that can be broken down into 2 times 2. We'll bring down this 3. And then 18. let's write that as 3 times 6. The 6 can be broken down into 2 times 3. We'll bring this 3 straight down. And 26 can be broken down into 2 times 13. Okay, so let's look at our greatest common factor here. So we'll start with the 2. I see that they all have a 2. This one has 2 2's, but the other numbers only have 1. So the greatest factor 2 that they all have in common is just a single 2. And then I see a 3 here, and I see a 3 here, but not here. And then the only other prime factor was 13, and only one of the numbers had a factor of 13, so we cannot include that. It would have to be in all 3 of them to be able to be included. So the greatest common factor of 12, 18, and 26 is 2. In numbers 5 through 8, we need to find the least common multiple of each set of numbers. So we will still be able to use the factor trees, but we'll use them a little bit differently. Well, let's go ahead and list multiples. Let's do that with the first one because I think that has the smallest, that'll be the shortest list, okay? So when we have least common multiple, we can make a list strategy, use the make a list strategy. So 5, 10, 15, 20, 25, 30, and then hopefully by knowing our math facts, we know that this 6 will go to 30, so we can stop there. And factors of 6 are 6, 12, 18, 24, and 30. And so then we see our least common multiple is 30. And then if we wanted to do the factor trees for this, okay, so 5 is prime already. We wouldn't be able to make a factor tree. It's a prime number already. And then 6 can be broken down into 2 times 3. So when we are looking for the least common multiple using factor trees, we're looking for numbers that occur in at least one of the numbers. It doesn't have to be in both of the numbers or all 3 of the numbers if you have a 3-number problem. Okay, so we already know from our list that the least common multiple is 30. That's our correct answer. But let's go ahead and do it with the factor trees as well. So we're looking for numbers. This is, again, different. We're still using factor trees like we did in GCF, but obviously finding LCM is different than finding GCF. So for LCM, we're looking for numbers that occur in at least one of the factor trees. Okay, it does not have to be in both. It just needs to be in one. Okay, so our least common multiple would be found by doing 2, because that occurs here in the 6, times 3, because that occurs here in the prime factorization of the 6 as well, times 5, which is its own prime number. We did not need to make a factor tree for that number. So then 2 times 3 is 6, times 5 is 30, okay? When 2 numbers don't have any common factors, like 5 and 6, they don't have any common factors other than 1. They're called relatively prime. Okay, when numbers have no factors in common at all, they're called relatively prime. Now 6 is a composite number, but relative to 5, it's prime. So they don't have any factors in common. They don't share any factors. So when you know that 2 numbers are relatively prime, which is pretty easy, if they're small and they both are just like 1 digit away, it's pretty easy to tell. But anyway, when you have 2 numbers that are relatively prime, you can find their least common multiple by multiplying them together. Okay, and you probably learned this in elementary school when you were looking for least common denominator in order to be able to add and subtract fractions. Okay, so we just did 2 separate methods for that same problem. So make a list strategy, list the multiples until you see the least common multiple, and then use the prime factor trees. Okay, so let's go ahead with 6 and 9. Let's use our prime factor trees. 6 can be broken down into 2 times 3, and 9 can be broken down into 3 times 3. And I'm going to make that a little neater. And so then we're looking for the least common multiple. and that's going to be, we're looking for factors that occur in at least one of the numbers, okay? So there's a 2 times, and then we look at the 3's. This has only 1 3, this has 2 3s. So we're going to use both of these, okay? We're not going to duplicate it. Well, this 3 is covered here, okay? Because that is it's a common factor, so we don't have to count that twice, okay? If we counted it twice, we wouldn't get the least common multiple. We would just get a common multiple. So then times 3 times 3. So we're actually taking the larger, larger quantity of that factor. It does not have to be in both. It just has to occur in at least one of the numbers. So then 2 times 3 is 6, times 3 is 18. So our least common multiple is 18. Okay, number 7, we have 6, 12, and 15. Okay, 6 can be broken down into 2 times 3. Those are both prime. 12 can be broken down into, let's do 3 times 4. The 4 can be broken down into 2 times 2, and we'll just bring the 3 straight down. 15 can be broken down into 3 times 5, and those numbers are both prime. Our least common multiple is equal to, and then again, we're looking for factors that occur in at least one of the numbers. Okay, so we'll start with our smallest number, 2. So we have 1 2 here, but we have 2 2's that are factors of 12. So we're going to use both of those, 2 times 2. That's the largest set of factors of 2. And then we'll move on to the 3. We have a 3 here, a 3 here, and a 3 here. So they all have a 3. That's what they have in common. Okay, and then we're moving on to 4 is not prime. Moving on to 5. Okay, so that is occurring here in the 15. And we don't need it to be occurring everywhere. It just has to occur in at least one of the numbers. And then let's go ahead and multiply. 2 times 2 is 4, times 3 is 12, times 5 is 60. So our least common multiple is 60. Okay, and if you're not sure when you're working on your own problems, remember you can use this strategy to double check where you list the multiples until you become a little bit more confident with working with the factor trees. Okay, so then let's go ahead and look at number 8. We have 3 and 9 and 15. Okay, so 3 is prime, so we don't need to make a factor tree for that. 9 can be broken down into 3 times 3, and 15 can be broken down into 3 times 5. And so we're looking for factors that occur in at least one of the numbers, LCM. Okay, so let's start with the smaller number, which is 3. There's 1 3. That's a factor of 3, obviously. But here with the 9, we have 2. So we'll take the larger. So 3 times 3. And then the next largest factor is 5. And there's only one of them anywhere, so we use that 5, that single 5. Okay, 3 times 3 is 9, times 5 is 45. A gardener has 27 pansies and 36 daisies. He plants an equal number of each type of flower in each row. What is the greatest possible number of pansies in each row? So we have these two numbers, and we're trying to plant them in rows with equal number of flowers. So 27 pansies, 36 daisies, and we want our rows to match up. Okay, so 27 can be broken down into 3 times, and so we're looking for the greatest common factor. Okay, we're looking at breaking these down into rows. Okay, we're not making it larger like with a multiple. We're not getting additional flowers. So these are the number of flowers that we have, and we're just breaking those down into rows to look for nice even numbers to plant. And so 27 can be broken down into 3 times 9, and then 9 can be broken down into 3 times 3, and I'll just bring that 3 straight down. And then 36 daisies, so 36 can be broken down into 6 times 6. And each 6 can be broken down into 2 times 3. And then so we're looking for the greatest factor they both have in common, greatest common factor. So our GCF is, and we'll start with our smallest number 2. So this has a 2, this has a 2, or has 2 2s, but the 27 doesn't have any 2s. So they do not have a 2 in common, so we can't write that down. Then we come over to the 3s. 27 is equal to 3 times 3 times 3. There are 3 3s. And we look at 36, there are only 2 3s. So the greatest number of 3s that they have in common is 2. So that's 3 times 3, which means our GCF is 9. And I'm just going to make that 3 a little bit neater. So our GCF is 9. So we can plant 9 flowers in each row, or 9 pansies in each row, excuse me. Number 10, 14 boys and 21 girls will be equally divided into groups. Find the greatest number of groups that can be created if no one is left out. So 14 boys and 21 girls. We want to know what's the largest number of groups that can be created. So if we want a large group, there are fewer people per group. Okay, which is nice for kind of getting to know each other. So 14 is equal to 2 times 7. 21 is equal to 3 times 7. Okay, so the greatest factor they both have in common is 7. So our GCF, that's all they have in common. The 2 and the 3 are not common. So our GCF is 7. Okay, let's go on to page 12. Inez waters her plants every 2 days. She trims them every 15 days. She did both today. When will she do both again? So we're looking for the least common multiple. So when's the next, how many days from today will she be doing both again, watering and trimming? Okay, so we're looking at least common multiple for this question, LCM. And we're looking at she's watering every 2 days. Okay, that's I can't make a factor tree for that, it's already prime. And then she's trimming every 15 days. So this I can break down 3 times 5. And then we're looking for the least common multiple because we want to know how many days from now will she be doing that again. So we're looking for factors that occur in at least one of the numbers. Okay, so our least common multiple, 2 times 3 times 5, because none of the numbers repeat. Okay, and there are no duplicates, so it's just 2 times 3 times 5. 2 times 3 is 6, times 5 is 30. So in 30 days. And then number 12, identify repeated reasoning. An airport offers 2 shuttles that run on different schedules. If both shuttles leave the airport at 4 o'clock p.m., at what time will they next leave the airport together? Okay, so we're looking for the least common multiple here because we're looking at how many more minutes will pass. So we're not breaking these down. We're just looking for when is the next time that they will both leave at the same time again. Okay, so we know right now 4 o'clock, they both just left the airport at the same time. So when is the next time those 2 drivers will be leaving the airport at the same time again? So we're looking for least common multiple of 6 and 9. And then once we get that, we're going to add it on to 4 o'clock. And that's going to be in minutes. Okay, so 6 and 9. 6 can be broken down into 2 times 3. 9 can be broken down into 3 times 3. Since we're looking for the least common multiple, we're looking for factors that occur in at least one of the numbers. It doesn't have to be in both. So they have 2. And then as far as 3s, we have more here than there. So we're not going to count this here and here. We're just going to count these 2, okay, because that covers this 3. So 2 times 3 times 3. 2 times 3 is 6. Times 3 is 18. So our least common multiple is 18. But in the context of our word problem, we were asked at what time will they next leave the airport together. So it's 4 o'clock currently. 18 minutes after that, it'll be 4:18 p.m. So at 4:18 p.m., both shuttles will leave the airport. And it's pretty intuitive when you're trying to decide whether you're in the word problems, when you're trying to decide whether to find the greatest common factor or least common multiple. You just need to ask yourself in the word problem, is my answer something that's going to be bigger than my original numbers or something that's going to be smaller? If it's bigger, it's a multiple, least common multiple. And if it's smaller, it's a factor or greatest common factor. Okay, so that was today's assignment on Chapter 1, Lesson 1, greatest common factor and least common multiple.